Hey everyone, today I'm excited to talk to you about the latest Rekha Flash 3 model, which is a general purpose open source reasoning model which was trained from scratch on synthetic and public datasets by supervised fine tuning, followed by instruction tuning and RLOO strategy, which is based on model based and rule based rewards. So, this model particularly excels in general conversation, coding support, instruction following, function calling, and even reasoning, and it offers competitive performance compared to models like OpenAI, OpenMini, making it ideal for applications requiring low latency local device deployments or even testing. So let's look at the key features for this particular model. So it's a 21 billion parameter model which can process up to 32,000 tokens, which is its context window length. Now it has a budget forcing mechanism which uses reasoning tags and allows users to limit the number of processing steps. And it has multilingual support, although it is primarily designed for English, but however, it demonstrates some understanding of other languages as well. And on device deployment, it can be compressed to 11 GB using 4-bit quantization, which allows us to efficiently use this model for our local deployments. So let's see the training process for this particular model. So it is particularly trained using a three-step approach. So first, it was pre-trained on synthetic and publicly available dataset, followed by instruction tuning for performance enhancement, then reinforcement learning using reinforce leave one out sample strategy. And this strategy is actually based on using both model-based and rule-based awards. And what are model-based and rule-based awards? Basically, a model-based reward is using a strategy where you are rewarding the action of a model based on the model's prediction. So you're estimating the outcome of an action, and we compute the reward basis the prediction of the model. Whereas the rule-based rewards are actually, it works like the predefined rules or criteria which are set based on which the model's actions are evaluated. So a model should avoid, for instance, if a model should avoid repetitive reasoning, and if it violates this rule, so a lower reward will be assigned. So we call this a partial reward or even a lower reward, which will be assigned if the model fails to pertain to the predefined rules. And that is how we charge a penalty or reward the model for this particular purpose. So we can see the formula for reinforcement learning, which we mentioned over here, which uses the old parameters along with the policy parameter, which is the probability of taking an action A in state S, and R is the cumulative award, subtracting the baseline function, which is used for reducing the variance and bias. So this RLOO strategy basically is used for leaving one sample out during the training. So when it leaves just one sample from the dataset during the training, it helps in reducing the bias, improving generalization, because when the model has less information to be trained on, then it tries to generalize even with the missing data. And this way, it also does not get biased to one particular data point. So this is an article which we have actually written and published on Medium, which you can refer. So there are multiple use cases for this particular model. So you can actually run it with Hugging Face using this, even using their official Hugging Face website, where they have mentioned the code snippet for running this particular model. Other than that, you can also run it with VLLM. And since it's open source, you can run it with OpenRouter as well with their free API key. And you can integrate this with Line and other applications also in order to automate your day-to-day tasks. And Olama also is supporting Rekha Flash 3. So you can run this with Olama as well. So let's see how we can actually implement it. So this is my collab notebook where I'm going to be implementing the Rekha Flash 3 model using the Hugging Face. So for this purpose, you have to just run these libraries first. You have to import it, and then you have to install bits and bytes in order to compress this to 4-bit quantization. So after you do these two steps, you have to use this particular code in order to quantize it to 4-bit so that it can do faster processing. So after your model gets loaded over here, it will take some time. So over here, we're actually using Rekha Flash 3 to solve a simple mathematical problem. And we are assessing its reasoning capabilities for this particular purpose. So let's see how it performs. So it takes about 2 to 3 minutes to actually run it, based on the type of the particular application which we are using it for. So for this particular use case, it takes around 2 to 3 minutes in order to generate a response. So it has actually generated the response. So we have to find all the values of x that satisfy this particular equation, and you can see how it has generated its response. Where first it says the human, which is our response, the mathematical problem which we need to solve, which we have given the model to solve. So here we can see how its thinking process and chain of thought process, and how it is actually at the end giving us the final answer. So just like we have the reasoning steps in the benchmark models like ChatGPT, over here as well, we can see how the response is being generated. And it also gives us different cases in which the answers can be considered. So over here, as you can see, since both the cases can be written, and which is equivalent but with different starting points, combining these two sequences, the solution is this. So it's actually a particularly a very good use case in order to just assess the model's performance. So this was the implementation using Hugging Face. You can also, just like I said, you can use Open Router using you can just post to this endpoint and get your and you can use this particular model, or you can also run it with OpenAI through Open Router. Over here, as you can see, on AIME 24 and 25, it has generated impressive results, which is comparable to O1 mini model, and compared to 32 billion parameter Quen model, it is at par with the model. Also, when it's coming to mathematics competition as well, which is Math 500, over there also we can see the same competitive performance of this particular model. Apart from this, on MMLU Pro, which is testing the reasoning capability of the model, we can see that this model is at par with 32-bit Quen model and Gamma model. So we can definitely, it's a enhanced model which can be used for our daily tasks, and it's a significant step forward in AI, offering a balance of performance and efficiency. And its open source nature and compact design, it makes it a practical choice for organizations who want to harness AI without excessive resource demands. So this is Rekha Flash 3. Thank you for watching the video.